Hello everyone, I am Kritika Tank. Today I am going to be presenting on the topic hierarchical routing. In the upcoming slides, we will be talking about hierarchical routing, the primary goals of hierarchical routing, types of layers involved in hierarchical routing, operations of hierarchical routing, advantages of hierarchical routing, and drawbacks involved in hierarchical routing. So let's take a moment and look at the contents. Now, let's talk about hierarchical routing. Hierarchical routing is a networking concept that involves organizing a computer network into a hierarchy or a structure to facilitate efficient communication and data transmission. In hierarchical routing scheme, the network is divided into multiple levels or layers, and each level is responsible for a specific set of tasks. In the given figure, we can see a base station BS being a central head for cluster heads and which are like central heads for the sensory nodes. Now let's look at primary goals of hierarchical routing. Scalability. As a network grows in size, managing and routing data becomes more challenging. Hierarchical routing helps addressing this issue by breaking the network into smaller and more manageable sections. Reduce complexity. By organizing the network into layers, each layer can focus on specific tasks, reducing the overall complexity of routing. This makes it easier to design, implement, and maintain the overall network. Improved performance. Hierarchical routing can enhance the performance of a network by reducing the number of devices that needs to be considered during the routing decisions. This can lead to faster and more efficient data transmission. Types of layers. Backbone or core. This layer forms the backbone of the network and is responsible for high-speed, long-distance communication between different subnetworks or regions. It usually handles the majority of network traffic and is designed for high capacity and reliability. Distribution or aggregation layer. This layer aggregates traffic from different layers across the layers and connects them to the backbone layer. It helps in controlling and managing the flow of data between different parts of the network. Access layer. This layer represents the edge of the network and is responsible for connecting end user devices such as computers and printers to the rest of the network. It deals with the local connectivity and provides a bridge to the distribution layer. Operations of hierarchical routing. Hierarchical structure. Hierarchical routing organizes network nodes into a hierarchical structure. Nodes are grouped based on administrative domains, geographical region, or network boundaries. Hierarchical addressing. Nodes in hierarchical routing are assigned hierarchical addresses. Addresses often consist of multiple levels representing different administrative or geographical domains. Routing tables. Each node maintains a routing table containing information about how to reach each destination within each hierarchical levels. Routing table includes summarized information about lower level networks to reduce size and complexity. Routing information exchange. Hierarchical routing protocols facilitate the exchange of routing information between the node at each hierarchical levels. Protocols use mechanisms like aggregation and summarization to efficiently distribute routing exchange. Routing aggregation. Routing aggregation involves combination multiple networks prefixing into larger summarized prefixes, reduces the size of routing table and minimizes the amount of routing information exchanged. Routing hierarchy establishes a hierarchy of routing domains with high-level node magnifying traffic between larger geographic regions or administrative domains. Lower level nodes handling routing within smaller subdomains. Scalability and efficiency. Hierarchical routing ensures scalability and efficiency in larger scale networks. Effectively manages routing information and reduces overhead, allowing network to scale while maintaining performance. Optimization. Hierarchical routing optimizes routing decisions by organizing node into logical groups, minimizes the number of routing decisions required to reach a destination. Now, we will look at the advantages. Scalability. One of the primary advantages of the hierarchical routing is its scalability. As a network grows in size and complexity, the hierarchical structure allows for the organization of device into manageable groups or layers. This makes it easier to handle large-scale networks without sacrificing performance. Reduced complexity. Hierarchical routing reduces overall network complexity by breaking down the network into layers, each with specific responsibilities. This modular approach makes it easier to design, implement, and troubleshoot the network. Network administration can focus on tasks relevant to each layer without being overwhelmed by the entire network's integrities. Efficient resource utilization. The hierarchical structure enables efficient resource utilization. Devices with the same layer typically share similar characteristics and responsibilities. This allows for more efficient use of resources such as bandwidth with each layer and ensure that specific layers are optimized for their design functions. Simplified routing decisions. Routing decisions become more straightforward in a hierarchical routing environment. Devices within the same layer follow similar routing rules, and higher layer devices handle broader, long distance communication. This simplification of routing decision contributes to better overall network efficiency. Enhanced security and access control. The distribution layer in a hierarchical network often plays a role in access control and security. By consolidation security measure at this layer, administrators can enforce policies and control access to resources more effectively. This can help in securing sensitive information and preventing unauthorized access. Ease of maintaining and controlling. Troubleshooting and maintaining are simplified with hierarchical routing. Network administrators can isolate and address issues with specified layers without affecting the entire network. This isolation makes it easier to identify and solve problems, reducing downtime and enhance overall network reliability. Improve performance. Hierarchical routing often leads to improved performance. By organizing the network into layers, routing decisions become more localized and device can communicate more efficiently within their respective layers. This can result in reduced latency and fast data transmission. Adaptability to changes. Hierarchical routing provides a flexible structure that can adapt to changes in the network size or configuration. As new devices are added to or network requirements evolve, adjustments can be made with specific layers without requirement a complete redesign of the entire network. Now let's look at the drawbacks. Rigidity. The hierarchical structure may become too rigid and less adaptable to changes in network requirements. If the organization needs evolving in a way that the entire existing hierarchy cannot accommodate, it may require significant redesign and restructuring of the network. Single point of failure. The hierarchical design can lead to a single point of failure, especially in the core layer. If the core layer experiences a failure, it can significantly impact entire network's performance, causing the disruption in the communication between different parts of the network. Complexity in the design. While hierarchical routing aims to reduce overall complexity, the initial design of a hierarchical network can be complex. Determining the appropriate number of layers, the hierarchical depth, and the routing protocols can be challenging and may require careful planning. Increased latency. Hierarchical routing may introduce additional latency in communication, especially when data needs to traverse multiple layers. When the local communication within an access layer is efficient, communication between different layers can add some delay. Suboptimal routing. In certain situations, hierarchical routing may lead to suboptimal routing decision. For example, if a direct path between two devices in different access layer is available, but the traffic is forced to go through distribution and core layers, it can result in increased latency and inefficient resource usage. Challenges in local balance. Local balancing across different layers can be challenging. Ensuring that traffic is evenly distributed among paths in a hierarchical network may require careful configuration and monitoring.